In this video, we're going to learn about the basics of set notation. This video is a precursor to learning about probability in Chapter 4. Please use the guided notes to follow along. First, we have some vocabulary. First, we have a set. A set would be any collection of objects. The names of the people in your family would be a set. The ages of the people in your family would also be a set. Now, those particular objects or items or members, those are called the elements of the set. So to name set, we usually use capital letters. Each element in the set is listed only once. So, say our set was the names of the students in our class. If we had two class members named John, we would still only list John once in our set. What the difference would be is our set would not be a uniform set because each item wouldn't have the same weight or probability of occurring. In a uniform set, each item has the same probability of occurring. If I put all of the names of our class members in a hat and there were two named John, it would be more likely that we would draw John from the hat because John's name would be in there twice and everything else would be listed once. When you write a set, the order doesn't matter. As a convention, we usually write our numerical sets in increasing order, but really order does not matter. There's some symbols that we're going to encounter. The first symbol looks kind of like a curvy E. It's used to tell us that an element belongs to a set. If you see that curvy E with a slash through it, it means does not belong to the set. Now here's another particular rule. You may have seen a 0 with a slash through it. What that means is empty set. Empty set is a notation. It's not the same as saying the number 0. So if you're a person that writes 0 with a slash through it for the numeric 0, please don't. It means empty set. Let's look at an example. The ages of the people in the Fitzgerald family are as follows: 36, 38, 4, 4, 7, and 9. Let's call the ages of the family set F. We can say set F has ages 4, 7, 9, 36, and 38. Notice that I only listed 4 once, even though there are 2 members with the age 4. They must be twins. This is also equivalent to saying F equals 4, 38, 36, 9, 7. See, these are the same. The only thing that's different is the order I put them in. We can say that 4 belongs to F, but 11 does not belong to F. Why? Because 4 is in the set. 11 is not in the set. A set should be well defined. 2 ways we often see sets defined include a roster method, which is what we did in the Fitzgerald example. All the elements were listed. But then there's also a method called the set builder method, in which the rules are defined that each element must meet. So here we have a set D using the roster method. There are 3 items: -4, -3, and -2. But we can also write set D using our set builder method. Here we have set D, which is composed of elements X. And this line here means where. So elements X, where X belongs to Z. And Z represents integers. It's a universal notation. Capital Z is the set of integers. So we have X where X belongs to the set of integers Z, comma. That means that here's a rule coming up for those integers Z. So integer Z, where X is between -5 and -1. So all of the integers between -5 and -1 belong to our set D. The notation says X where X belongs to the integers and X is between -5 and -1. So note, we have this vertical line here that means where, and the comma means and. When we start talking about probability, we'll have a lot of problems for probability that have union and intersection. Intersection of two sets, A and B, would be called A union B, and the elements in common to both, A and common to B. So when we see A union B, sometimes we'll say A and B. Elements must be in both sets. For the union of sets A and B, which is A union B, all the elements are in A or in B or in both. So when we see A union B, we may write that as A or B. So if you hear the word or in a problem, it is a cue that it's a union of sets. And is a cue that we're looking for an intersection. Let's pretend the Fitzgerald family from the previous example is friendly with the Hammond family down the road. The ages of the members of the Hammond family are 42, 38, 7, 9, 12, and 15. So we have our sets written here for the Hammond family and for the Fitzgerald family. We need to find F union H and H intersect F. So what we're going to do is we're going to draw a Venn diagram. We have two circles. The first circle on the left is going to represent the Hammond family. And for the Hammond family, anything that falls in this blue circle is in their set. Next, we're going to draw a Venn diagram for the Fitzgerald family. Anything that falls into the yellow circle is part of the Fitzgerald family's set. You can see in the middle here, we have green. This is where they overlap. This is their intersection. Going through the list for the Hammond family, we have first the age of 7. Well, 7 is also in the Fitzgerald family, so I'm going to put it in the green. We have 9, which occurs for both families, so I'll put it in the green area. 12 is only for the Hammond family. 15 is only for the Hammond family. 38 occurs in both families. And 42 occurs for the Hammond family. Looking over at the Fitzgerald family, I haven't used 4 yet. So I'll put that for Fitzgerald. We'll have 36. And that is all the numbers. I need to find F union H. Remember that union is or. The items need to be in one or the other, or both. So basically, I'm looking for all of the items between F and H. So first we'll look for the items in F. F has 4 and 36. Next we'll look for the items that are in H. 12, 15, and 42. The items in both would be 7, 9, and 38. So the set F union H has 4, 36, 12, 15, 42, 7, 9, and 38. Now let's look for F intersect H, or H intersect F. F intersect H and H intersect F will be the same thing. Remember, our keyword here is and. So we're looking for the items that are in H and in F. That's represented by the green intersection here. So H intersect F will include 7, 9, and 38. Now, let's pretend the Gagnon family moves into the neighborhood down the street. The members of this family are ages 42, 38, and 12. You'll see here to the right, I've added a pink circle to our Venn diagram. Now, right here in this blue, darker blue section, That represents where H and G overlap. This more orange section on the right represents where the Gagnon family and the Fitzgerald family overlap. In the center here, where we have this dark green spot, that's where the Hammond, Gagnon, and Fitzgerald families have an age that all overlaps. That would be the intersection of all three areas. Go ahead and fill in your Venn diagram with the data, and then we'll check in. Pause the video now. Now we need to find G union H. So that means that the numbers are in the Gagnon family, in the Hammond family, or in both. We can see here, the blue circle has all the numbers in the Hammond family. We have 15 is just in the Hammond family. 7 and 9 is just in the Hammond family and not the Gagnon family. But 12 and 42 are in the dark green section. The dark blue section. That means that they are in Hammond and Gagnon family. And 38 is in the Hammond and Gagnon family, but also in Fitzgerald. But for this problem, it doesn't matter whether it's in the Fitzgerald family or not. So we have the numbers 15, 7, 9, 42, and 12, 38. Now we have F union G, meaning the numbers are in Fitzgerald or Gagnon or both. Well, in just the Fitzgerald family, we have 4, 36, 7, and 9. There's nothing in the dark orange section, which is where Gagnon and Fitzgerald overlap without belonging to Hammond. But in the dark green section, we have 38, which is where all three overlap. But once again, for this problem, we don't care if it's in Hammond or not. So we get F union G is 4, 36, 7, 9, and 38. Now we need H intersect G. So those are the numbers that are in the Hammond family and in the Gagnon family. First, we'll look at this dark blue section. So 12 and 42 are in Hammond and Gagnon, but also in the dark green section. That's also an overlap of H and G. It just also happens to have F included. 38 is there. So H intersect G is 12, 42, 38. Now we need G intersect F. So that's the numbers that are in both G and F. This dark orange section that is where just G and F intersect is empty. But that doesn't mean they don't have an intersection, because the dark green section, which is where all three intersect, has a 38 in it. So that means there's a 38 in the Gagnon family and in the Fitzgerald family. Final note is events A and B are called mutually exclusive if they have no elements in common. That would mean A intersect B is an empty set. So if we have no elements in common, we're going to call something an empty set. But it's also mutually exclusive. Here in this example, we don't have any mutually exclusive items because there's no empty sets.